Okay, guys, in this video, we're going to look at review of basic derivatives, but this time it's going to be a derivative of a vector valued function. What does that mean? Basically, you have a vector, but for each value of the parameter, you will get a different vector. So when t equals 1, you get one constant vector. When t equals 2, you get another constant vector. So it is just like, imagine three functions. Each one has a variable t in it, but now you're combining them in a vector so that for each value of the parameter, you have a constant vector. And when we take the derivative of something like this, where you have like some f of ti plus g of tj plus h of tk, the way we do that is we just take the derivative of each part. Okay, very simple to remember. We just take the derivative of the first component I plus the second component j and plus the last component derivative k. That's the rule how we take the derivatives. Okay, so basically this is like three problems in one. Okay, now the other two components are actually pretty easy, but the first one is where we're gonna have to review something called product rule. So let's go and do that. So what is product rule? Hopefully you remember this from your calculus days, but if you do not, let me just remind you. So whenever you have a product of two functions, when you take the derivative, you're gonna not, big NOT, take the derivative of the first function multiplied by the derivative of the second. That is absolutely not what you want. You want to take the derivative of the first one, multiply that by the second, plus derivative of the second one multiplied by the first one. So f prime g plus f g prime. That's what product rule says. And I'm going to apply that rule to negative 9t natural log of t. Now, why do I need a product rule here? So whenever you have a product where this part has the variable and this part also has a variable, so t is present, so t or whatever variable, x, whatever, if the variable is present, oops, let me spell the present, let me do it again, present in both, then we use product rule. We need to use product rule. If, for example, one of those parts was just a number, if it was just a number, you can use the constant multiple rule, which just says, well, keep the constant and you don't need any special rules. So if this was just negative 9 natural log of t, that would just negative 9 would stay and that's it. So only use product rule when you have a product of two things and both of them has an unknown in it. Okay, so let's do it. Okay, so according to the product rule, we take first the derivative of the first function. This is your f. And derivative of negative 9t is just negative 9. So remember, negative 9t is a line. The slope of that line is negative 9. So derivative is the slope. So that's where you get that negative 9 from. Multiplied by g, and g is natural log. Okay, so that's going to be no change. By the way, never try to put that negative 9 inside natural log. That does not work. You cannot do that, okay? Plus, now it says f, well, f is negative 9t, multiplied by the derivative of g. So hopefully you remember that derivative of natural log of t is 1 over t. Again, that was one of those basic derivatives that everybody needs to memorize. And at this point, especially if they said simplify your answer, you are supposed to notice that this t right here is cancel out. So this is going to become negative 9 natural log of t minus 9. Okay, so that's the ith component. It's going to go much faster. Don't worry with the second one. So here we go, negative 5 e to the power 5t. So even though here we do have a product, because you know the default operation is times, so you would think that this is going to be a times. But do I need product rule? No, I do not, because this first part does not have the variable. This part has a variable. This t is present, but not the other one. The other one is a number, and we just keep the number according to the constant multiple rule. So don't try to use product rule. You can, you would get the same answer because derivative of -5 is going to be 0. And so you will get the same answer. It's just an overkill. You don't want to do that when you don't have to. So this is where we just keep the -5 as a constant multiple. We keep it. And then derivative of e to the something t, number t, is the same. So e to the 5t. So remember, e to the at is a e to the at. It's not at e to the at. Again, let's write this down. Memorize it. Put it on your bathroom mirror. You do not want to forget this one. No t's. We're not using power rule, God forbid. No, we just bring in the constant to the front. Okay, and that become -25 e to the power 5t. Okay, so that's the jth component. Let's go to the kth component. Okay, so this one is going to be cosine t plus 9 sine t, derivative. Now, here we're using the property of derivatives. Then whenever you are adding things, you're not multiplying, you are adding or subtracting. Then you just take the derivative of each part and add or subtract it, okay? So let's do that. Okay, this is not product, don't need the product rule. This is a sum, so just derivative of each part, add them up. You promised me to memorize that derivative of sine is cosine. Derivative of sine is cosine. Derivative of sine is cosine. Okay. So then, if you memorize that, then you would remember that the derivative of cosine will not just be sine, it's going to be negative sine. So as long as you remember that one of them is negative, but you also remember that sine is cosine, then you're not going to make a mistake. So derivative of cosine is negative sine t. And 9 is a constant multiple, right? Because it's multiplied, but it's a number, so we do not need product rule or anything. We just keep the number. So if it's a number, we keep it. Constant multiple, we keep it. And derivative of sine is cosine. Okay, so that's the last part that we're going to be done here, hopefully. Plus 9 cosine t. Let's submit and see if that's right. Yay.